Well, good afternoon, everyone, and thank you for this invitation to speak at this webinar. My name is Bart Lardner, and I'm a professor in the Department of Animal and Poultry Science here at the University of Saskatchewan. And today I want to talk about beef cattle management and the environment. We look at the evolution of the beef cow today, we need to go back and look at its ancestors, the thousands and thousands of ruminants that roamed the northern Great Plains, and the evolution into what we see today as the modern beef cow. We can look at some numbers. In fact, going back to the 1800s, we see approximately 40 million bison roam the northern Great Plains, utilizing these vast grasslands. Today, we see in the US approximately 30 million beef cows, in Canada 4 million beef cows, and here in Saskatchewan 1.1 million beef cows. But beef cows serve a very important purpose, and that's to utilize those vast acres of forages and grasslands. In fact, the Western Canadian prairies are the ideal location for beef cattle production today. Looking at the amount of acres of pasture and rangelands in all of Canada, approximately 40 million acres of largely land that's not arable, marginal land that we cannot grow cash crops, but certainly we can put a beef cow out there and turn it into a saleable product. Here in Saskatchewan, approximately 15 million acres of both tame seeded forages and native rangelands. And so we conduct a lot of research here at the Livestock Forage Center of Excellence, focusing on applied beef and forage research. A little anatomy: the beef cow has 4 stomach compartments, so the largest of these is the rumen, hence the term ruminants. But what's really amazing about the beef cow, it's the ability to upgrade plants of little nutritional value to humans into high quality protein. Thus, the beef cow is known as an upcycler, taking these high cellulosic, low quality forages and converting them into high quality protein, micronutrients, and other important products. How does it do this? It does it through a fermentation process, through a relationship with rumen bugs made up largely of bacteria, viruses, and protozoa. So once the feedstuffs enters the rumen, a fermentation process takes place. The byproducts or the end result of this is volatile fatty acids, 3 volatile fatty acids, acetic, butyric, propionic, which are largely used as nutrient sources for the beef cow. And also an awful lot of gas is produced, which is eructated or burped off by the animal over a daily basis. And through this intermicrobial fermentation, and it's directly proportional to dry matter intake. One thing to note is that methane is about 25 times greater greenhouse gas effect compared to carbon dioxide. What's really interesting, however, is this methane that's eructated by the grazing beef cow consuming these structural and unstructural carbohydrates. After 10 years, we see a photochemical oxidation process converting the CH4 into CO2, which is cycled back down through photosynthesis, taken up by the plants, and thus the whole cycle begins. When we look at the other carbon source entering the atmosphere, burning of fossil fuels, which is old photosynthetic carbon, this is presently not in the carbon cycle, and this then is accumulated in the atmosphere. Thus, we've exceeded the ability of the atmosphere to take up CO2 from fossil fuel burning by the plants in the oceans. And what's also interesting to note, since the lockdown in 2020, since January 2020, worldwide greenhouse gas emissions have reduced by 17 million metric tons. So we've been burning a lot less fossil fuels, but there's still the same number of cows. So something to consider. A little bit about the carbon cycle and sequestration. The beef cow is so important with this. We know that the plant is using photosynthesis to take up CO2 from the atmosphere. There's also a respiration process taking place. We see carbon in the grass, carbon in the roots, liquid carbon in exudates. Thus, the grazing cow is maintaining and is sourcing its carbon from the plants that it eats. And so that's where all the carbon in the cow is being eructated, is from the forages and the plants that it's consuming. But it's this grazing, this disturbance that triggered by the grazing cow to complete the cycle of moving the carbon through the cow, eructated to CH4, converted to CO2, back through photorespiration and photosynthesis back into the plant. Another interesting thing is that beef cows do return a large portion of excreted manure nutrients into the soil. And so we have systems out there that we can take advantage of the daily manure and urine excretion, thus the level of nitrogen and phosphorus deposited on different acres or different areas, nutrient deficient areas of a farm or a ranch, and thus taking advantage of this excretion process. We've seen some past research conducted looking at the change in the Canadian beef industry footprint between 1981 and 2011, and thus they concluded that producing the same amount of beef in 2011 that produced 15% less greenhouse gases than compared to 1981, and thus these reductions largely through technologies that improve production efficiencies, and so integration of ionophores, feed additives, these types of things. In my mind, are probably the most sustainable individuals that I know of. Their objective is to leave resources better condition for the next generation, thus the plants, the soil, the atmosphere, the land, the water that they have control of. And also important to understand, the Canadian beef production accounts for only 0.04% of global greenhouse gas emissions and only 2.4% of Canada's greenhouse gas emissions. Let's just turn our attention to some research. We know that legume plants, through a symbiotic relationship, are able to fix atmospheric nitrogen. So thus, let's have more legume plants in these pasture systems and integrate beef cows with these pasture systems just to reduce these lower input costs. A couple of the forages that we've looked at in our research program are sandfoin and sisal milkvetch, two nitrogen-fixing legumes. And so what are the other ways we can, strategies we can use to mitigate GHG emissions in beef cows? We can feed high-quality diets with integration of feed grains. We can graze these high-quality immature pastures with the addition of these legume forages. How do we measure these emissions? A couple of techniques: a sulfur hexafluoride technique, where we put a yoke around a cow's neck, and then over a 24-hour period, able to capture those nasal emissions and measure her CO2 and her CH4 emissions. Another one, less invasive, is these greenhouse green feed trailers. We put them out and the animals are able to go to the trailer for a treat, and over a 2-minute period we can capture those nasal emissions as well in a grazing system in real time. Some of the work we've done just looked at integration of these legumes into pasture systems, and we found that we put sisal milkvetch into a pasture system, we saw reduced methane emissions and also greater cattle gain on those paddocks. So just to wrap up, a lot of pasture in lands in Canada, rangelands, 40 million acres. Beef producers are able to manage this, and thus we're taking the beef cow, it's able to cycle these inedible forages into high quality protein, removing carbon from the atmosphere and storing it into the ground through sequestration processes. These areas also provide tremendous wildlife habitat and thus enhance biodiversity. And finally, really do protect just marginal land from erosion. So with that, thank you very much for your attention and look forward to some questions.